The project objective was to develop a system to simultaneously collect both electroencephalograms and electromyograms, which are EEG and EMG data, and wirelessly transmit it to a user interface to be plotted and stored. We were given a budget of $1,500. The electrodes placed on the subject transmit biopotential signals to a custom-designed PCB for this project. The PCB shown is dedicated to the EEG system. Signal inputs are routed through labeled terminal blocks, with each terminal corresponding to a specific EEG or EMG channel. These low-amplitude signals are then amplified by individual bioamplifiers. There is one bioamplifier per channel to ensure sufficient amplification of the signal and proper differential for each signal. Following amplification, anti-aliasing filters are applied to reduce noise and prevent aliasing of the signal. The analog signals are then sampled by an onboard ADC module, which converts them into digital form. These digital signals are transmitted via SPI to an ESP32 microcontroller for real-time processing. Upon completion of the trial, the ESP32 transmits the recorded data over Bluetooth to a custom user interface for visualization and storage. The EMG PCB shown incorporates the same core technologies as the EEG PCB, but has fewer input channels, resulting in a more compact design. To set up the EMG system, the user must first prepare the skin using alcohol pads. Disposable gel pads connected to electrodes should then be placed along the longitudinal midline of the target muscle as close to the anatomical midpoint as possible. A differential signal is obtained from the positive and negative electrodes for each channel. The system supports different channel configurations based on the user's needs. Users may select either one or two channels for simultaneous recording over the full trial duration. Alternatively, a split mode allows the use of 2 or 4 channels, where the system records from half of the channels during the first half of the trial and switches to the remaining channels for the second half. This allows analysis of multiple muscle groups or alternating limbs, such as during single leg balance or fatigue studies. To prepare the EEG system, conductive electrode gel is applied to each electrode location to ensure a low impedance connection between the skin and the electrode surface. The electrode holders are interchangeable and can be removed and placed at different locations on the enclosure, allowing for full configurability based on the study design. Each holder is also individually adjustable to maintain consistent contact at every placement location. The headset is available in 2 size options, small, medium, and medium-large, to accommodate a wide range of head shapes and sizes. Once the electrodes are installed and fully loosened, the user places the helmet on their head. A chin strap and a front-mounted counterweight help stabilize and center the enclosure. All electrode positions follow the standard 10-20 system for EEG signal acquisition and are clearly labeled according to their respective locations.
I'm going to walk through some features of our GUI. If you're ready to begin a trial, you can select communication and connect to whichever device or both. Once it's connected to the device, a pop-up will show which device you're connected to, and you can select OK. For EMG, you will come over here and select your number of channels and the frequency you're looking to use in your trial, and then confirm that. After that, you'll see a pop-up asking if you want to split channels halfway through the trial. If you were to select no, it lets you know you would use channel 1 and 2, and if you select yes, it shows that you will use 4 channels. 1 and 2 will be recorded in the first half of the trial, and then it will switch to 3 and 4 for the second half. EEG is already connected, so if I went to select EEG channels, I can also select the number of channels I'm looking to record and the frequency, confirm this, and here we have an option to choose which electrode placements you are recording. So once you confirm that, a pop-up shows what channels you're using and their labels. You can select the time here and start and stop a trial. Here you can choose which you would like to display, either EEG or EMG, and this is to see the plot a bit bigger. And then here we have open files, open a combined file, save and exit the GUI. To begin a trial, make sure you are connected to your devices and then make any channel, frequency, or label selections for the trial. Here you can set the time and then press start when you're ready for the trial to begin. Here's a pop-up from the devices letting you know that the trial is started. This pop-up lets you know that the trial is completed, and in pressing OK, data transfer will begin. Here you can name the file and save it. Once a trial has been completed and the data has been saved, you can select File and open in either individual EEG or EMG or a combined file for a trial. Here I've done that already, and our EMG plot shows a split trial where it switches from channel 1 to channel 2 during the trial period. So when you open the plot, you can zoom in using your scroll wheel and then reset back to the original view. You can also pan along the data and zoom to certain regions. This allows you to configure the display, and here you can save the figure as an image file. Here you can select which plots you would like displayed if you want to focus in on certain data or a certain channel. And here you can do the same thing as well with the EMG data.